Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be reviewing how to solve quadratic equations by factoring. Before we do, let's get a couple of definitions under our belts. A quadratic equation is a polynomial equation with a degree of 2 that can be written in the form ax squared plus bx plus c is equal to 0, where a cannot equal 0. Now, the term quadratic comes from a Latin word quadratus, which means square, because all quadratic equations involve a term with a squared factor, or power, Now, an example of a quadratic equation might be something like 3x squared plus 2. Note this squared term. A non-example would be if you just had 3x plus 2. So if you graph the first expression, 3x squared plus 2, you're going to get a parabola. Whereas if you just graph 3x plus 2, you're going to get a linear shape to your graph. All right? So when we have a squared term, your expression will form a parabola when graphed. Now, one of the main ways you learned to solve quadratic equations in previous courses was to solve quadratic equations by factoring. Now, there's 3 steps when you're solving by factoring. The first step is to rearrange the equation so that all terms are on one side of the equation and the other side is equal to 0. Step 2, you will factor the quadratic expression. And step 3, you will set each factor equal to 0 and solve. Now, let's review this a little bit. In example 1, it says solve each of the quadratic equations below by factoring. All right, so step 1 said to rearrange the equation so that all the terms are on one side of the equation. So what I'm going to do here is I'm going to move the negative 2x by adding 2x. Now if I add 2x on that side, I have to add 2x on this side. And then I'm going to remove the positive 10 by subtracting 10 from both sides. Now let's see what that results in. So there was nothing to combine with x squared. 3x plus 2x is positive 5x. Negative 14 minus 10 is negative 24. And on the other side, negative 2x plus 2x is 0. 10 minus 10 is also 0. So the only thing we have left on the right side is 0. So we've completed step 1. Step 2 is to factor the quadratic expression. So to factor it means I'm going to split it into the 2 factors that when you multiply them together will give you x squared plus 5x minus 24. So to factor this, you'll start with your first term. To get x squared, we would have to use x times x. Now, to get to your last term, negative 24, I could use 1 times 24, 2 times 12, 3 times 8, or 4 times 6. Now, to choose which one of those to use, I want to look at this middle term. I want to know which of these terms could result in positive 5 when we add them. So the only pair of factors that could result in positive 5 is 3 and 8. Okay, so I'll put the 3 here. Oops, I wanted to put that in pink. I'll put the 3 here and the 8 here. Now, we need the 5 to be positive, so I want to make the larger factor 8 positive and the smaller factor negative. All right. Now, step 3, set each of these factors equal to 0 and solve them individually. So I'm going to take the first factor, x minus 3, make it equal to 0. And then I'll take the second factor, x plus 8, and make it equal to 0. So to solve this, I'd have to add 3 to both sides. So x, 0 plus 3 is 3. And over here, I'll have to subtract 8. So 0 minus 8 is negative 8. Now, you can write your answer separate like this. Generally, when we're solving quadratic equations, we'll write the solutions in braces. Now, when you use braces, what it means is that both of the numbers inside the braces are x values, as opposed if you were to use parentheses, 3 comma negative 8, then I would assume that the first one was x and the second one is y. So that's why we want to use braces and not parentheses. All right. Look at problem B. We have 3x squared plus 12x minus 7 is equal to x squared plus 3x minus 2. So in this problem, I want all the terms to be on the left side. So I'll subtract x squared from both sides. Then I'll subtract 3x from both sides. And then I'll add 2 to both sides. Now when we do that, 3x squared minus 1x squared is 2x squared. 12x minus 3x is 9x. Negative 7 plus 2 is negative 5. And that's equal to 0. All right, so we did step 1. We rearranged the equation so that all the terms are on one side of the equation. Step 2 is to factor the quadratic expression. So our first term is 2x squared, and the only thing that will give us 2x squared is 2x times 1x. Now our last term is 5. The only thing that'll give us 5 is 1 times 5. What I don't know, is it going to be 1, 5 or 5, 1? So to check that, I'll just start by trying 1, 5. And then to check it, I use the outer terms and the inner terms. So the outer term, 2x times 5, would be 10x. The inner terms, 1 times x, would be 1x. Now, you want to ask yourself this question. Can I get a 9x from 1x and 10x? And the answer is yes, if you were to make the 1x negative, because negative 1x plus 10x would be positive 9x. So in order to make that 1x negative, this factor would have to become minus, and this factor would have to become plus. All right, so now we've got it factored. Now we can set each factor equal to 0 and solve. So 2x minus 1 is equal to 0, or x plus 5 is equal to 0. So to solve this, I'll add 1 and then divide by 2. On the second one, I'll subtract 5 from both sides. And we've got our solutions. So I'll use my braces again. 1/2 negative 5. We have solved the equation for the value of x that would make the equation true. All right, problem C. We have 5x squared plus 2x equals 6 minus 5x. So on this one, I'll subtract 6 from this side, and there's nothing to subtract 6 on from this other side. So I'm going to squeeze it in right there. And then I'll add 5x. 5x under the 2x. All right, let's see what that gives us. 5x squared, 2x plus 5x would give you 7x. And then we have the minus 6. All right, now we will factor the quadratic expression. So for our first term, 5x squared, the only thing we can use is 5x times 1x. Okay. Now for the 6, we can use either 1 times 6 or 2 times 3. So we're going to have to use a little guess and check here. Now when I'm using guess and check, I try the two factors that are closest together first, 2 and 3. It doesn't always work, but generally it's a little bit quicker if you'll try the ones that are closest together. So I'm going to try 2 and 3. If 2, 3 doesn't work, then I'll try 3, 2. If neither of those work, then I'm going to move on to the 1, 6. All right, so let's try the 2, 3 first. So I'm going to put a 2 here and a 3 here and check the outer terms. That'd be 15x. And the inner terms. 2 times x is 2x. Now, you want to ask yourself, look at this middle term. Is there any way I can get a 7x from 2x and 15x? And there is not. So 2, 3 did not work. So let me try to erase this real quick here. Delete. Okay, so let's try 3, 2. So let's see what it looks like when we try 3, 2. So check the outer, 5x times 2, that would be 10x. Check the inner, 3 times x is 3x. And remember the question you ask yourself is, can I get a 7x from 3x and 10x? And the answer is yes, if I make the 3 negative, because negative 3x plus 10x would give me positive 7x. So now I know that the 3 has to be negative 3x, and this would have to be positive. All right, so once you have your factors, you're going to set each factor equal to 0 and solve. So add 3 and divide by 5. And on the second one, subtract the 2. So our solutions are 3 over 5 and negative 2. All right, now you have to be a little careful on this last one, and we'll talk about why here. We have x squared plus 2 plus 3x equals negative 2x squared plus 10x. So I'm going to start by adding 2x squared here and here, and then subtracting 10x here and here. So 1x squared plus 2x squared is 3x squared. Now, here's where you have to be a little careful. I want to make sure this is in standard form. So I need to find the sum of the x terms. So 3x minus 10x would be negative 7x. Then you would have your plus 2. So you just need to make sure that when you're writing your quadratic expression, that it's in standard form and the terms are all in the correct order. If you don't put them in the correct order, you're not going to be able to factor them properly. All right, so now we've got our quadratic expression. Now I want you to pause the video and try this problem on your own. All right, welcome back. Let's see how you did. All right, for my factors, I used 3x times 1x here, and I used 1 times 2 here, and I made them both negative. And the way I checked it was 3x times negative 2 would be negative 6x. Negative 1 times x is negative 1x. And when I combine those, negative 1x plus negative 6x, I get that middle term of negative 6x. So then I set them both equal to 0 and solved. And for the first solution, I got positive 1/3. And for the second solution, I got positive 2. So there's your solution set. Now, if you got any of that incorrect, pause the video while you fix anything that you got wrong. All right, welcome back. Example 2. The parabola shown at right has the equation y equals 2x squared minus x minus 15. Use the graph to approximate the zeros of this function. All right, so our zeros are found where the function, in this case a parabola, touches the x-axis. So I have a 0 right here, and I have another 0 right here. Now, this negative 0, it's a little hard to approximate because it's in between two integers. So we have -1, -2. It's in between -2 and -3. So I'm going to approximate it as -2.5. And then our second one, 1, 2, 3, x equals, that's what the zeros look like according to the graph that was given, all right? So the next thing we want to do is we want to write this function in factored form. Now, factored form means to just break it apart into its two factors. So for 2x squared, we would use 2x times 1x. For the 15, I could use 1 times 15 or 3 times 5. But remember, I usually, when I'm using guess and check, I start checking with the 3 and the 5 because they're closer together than 1 and 15. So I'm going to check 3, 5. If 3, 5 doesn't work, then I'll try 5, 3. So let's try 3, 5 first. Okay, so the outer would be 10x. The inner would be 3x. And I'm trying to obtain a -1x. A -1x. Now, there's no way I'm going to get -1 from 3x and 10x. So let me erase that. And we'll try again. But this time, I'm going to try 5 and then 3. All right. So what did I say? 5 and 3. So my outer term would be 6x. My inner term would be 5x. Oh, I can get a -1 from those if I were to make the 6 negative. So in order to make the 6 negative, I would have to make the negative go on x minus 3, because 2x times -3 is -6x. So that means this is positive. All right, now we have it written in factored form. Y equals 2x plus 5 times x minus 3. All right, problem C. Find the zeros, or x-intercepts, same thing as x-intercepts, algebraically. So to do that, I'm going to make the y equal to 0, and I'm going to solve this. So to solve it, you're going to take each factor and make it equal to 0. So here I would subtract 5 and then divide by 2. So -5/2. Now, when you write that in decimal form, you get -2.5. For our other 0, add 3 and x equals 3. Now, what I want you to notice that when we found the x-intercepts algebraically, it matched the zeros that we found from the graph. So our factored form can help you find the zeros or the x-intercepts of a function. And will you be using this property all throughout this course? All right. Example 3, write each of the following in factored form and then state the zeros or x-intercepts of the function. So in problem A, we have y equals 4x squared minus 1. We want to write that in factored form. Now, this is a difference of two perfect squares of the form a squared minus b squared. So let me just remind you, when you have two perfect squares, the difference of two perfect squares, you can factor it using this pattern, a plus b, a minus b. It's been a while since we've done that, so just wanted to review that with you, which that means that I could put this in factored form by putting 2x plus 1 times 2x minus 1. If I was to multiply those together, I would get 4x squared minus 1. Now, so we did the first part of the answer. We can box that in. They wanted us to write it in factored form, and we did. And the next thing they want you to do is use those factors to get the zeros or the x-intercepts. So our zeros would be -1/2 and +1/2. So there were two answers in this problem. All right, our second function, we have y equals 3x squared plus 13x minus 10. To write it in factored form, I'd have to draw two parentheses. Now, for our first term, 3x squared, our only choice is 3x times 1x. That's the only thing we can use. Now, for the 110, I'm going to either use 110 or 25. But I'm going to start with the two that are closest together, 2, 5. So what I'm going to do is put a 2 here and a 5 here. If this doesn't work, I'll switch it and use 5, 2. So when I multiply my outside term, I get 15x. And when I multiply the inside terms, I get 2x. Now, I'm trying to obtain a positive 13. And so I can do that if I make that 2x negative. So this factor needs to become negative. This factor needs to become positive. Okay. Now, let's delete that so that I can now box in my first answer. The factored form of this function is y equals 3x minus 2 times x plus 5. And then I want to get the zeros from that, so I'm going to draw my little braces. So my first zero would be positive 2/3, and my second zero would be negative 5. So those are the x-intercepts of your function. Now, in problem C, I only have two terms. So the only thing I can really do on this one is take out the greatest common factor, which would be 5x. So 5x squared divided by 5x would just leave me x. 10x divided by 5x would leave me 2. Now I'm going to set each one of those equal to 0 and then solve it. So here 0 divided by 5 would just give me 0. Here add 2, and that would just give me positive 2. Now, in our last example, it says write a quadratic function in factored form with each set of given characteristics. So in problem A, we have a parabola that opens downward and has x-intercepts of 2, 0 and negative 5, 0. So let me just kind of sketch what's going on here. All right, so 1, 2, 3, 4, negative 5. I have 1, 0 at negative 5. I have 1, 0 at 2, and I know it opens downward. So I have a maximum somewhere up here. I don't know where, but I do know, let's count how far apart these two zeros are. 1, 2, 3, 4, 5. They're 6 units apart, so I know I have a vertex at x equals negative 2. So maybe it's up here somewhere. I don't know exactly where it is, but this is just a rough sketch of what this function would look like. So again, this 0 was at negative 5, this 0 was at positive 2. So to write a function of that form, I would need a negative because the parabola opens downward. And then I'm going to take my first factor. My 0 was negative 5, so my parenthesis is x plus 5. My second 0 was at positive 2, so my second parenthesis is x minus 2. So we wrote a function to describe the given information. All right, in problem B, it says we have a parabola that opens upward, has an axis of symmetry of x equals 3, and has x-intercept of 1, 0. So let me try this one. So 1, 0 would be right here, and then 2, 3, 4, 5. Go up to 6. Now we have a axis of symmetry at x equals 3. So 1, 2, 3. That would be right here. Okay. Now they did not give us our other 0, but we can figure out what it is because from the first 0 to the axis of symmetry is 2 units. So I can go 2 units in the opposite direction, and I know I have a 0 right here. So this 0 was at 1. 1, 2, 3, 4, 5. And this 0 was at positive 5. Now, if it opens upward, I also know it has a vertex somewhere down here. I don't know exactly where, but it's going to look like something like this, okay? It has a vertex of 3, comma something. We don't know what the vertex is. So, to write my function, I'm just going to take that first 0, which was positive 1. So my first parenthesis would be x minus 1. My second 0 was at positive 5. So my second parenthesis would be minus 5. And there's my factored form. And that concludes today's lesson, a review of solving quadratic equations by factoring.